I want you to imagine, just for a second, that a major pharmaceutical company just held this massive press conference to announce a brand new drug.
Oh boy.
Right. And the clinical trials for this drug are just absolute showstoppers. The researchers get up on stage and say, look, we have a compound that can physically shrink the activation of brain regions associated with clinical depression.
Which would be front page news immediately.
Immediately. And then they say it also boosts your creative problem solving by a staggering 50%. It alters your autonomic nervous system, it changes your sweat gland activity, and it stabilizes your heart rate in literally a matter of minutes.
And let me guess the kicker.
The kicker is, they say, it has absolutely zero side effects and it's completely free.
Right.
If that happened, it would be the biggest news story of the decade. People would be lining up around the block for this stuff. But we aren't talking about a synthetic chemical here or some piece of futuristic biotechnology. We are talking about the natural world.
Yeah.
And the mission of our deep dive today is to really look at the hardcore, physically measurable ways that interacting with nature literally rewires your brain.
It really is, it's the ultimate preventative medicine. And yet it's something we culturally just treat as a luxury, like a nice to have. But I want to be clear right up front. We are not going to be talking about the subjective, poetic feeling of looking at a nice tree today.
Right. No poetry today.
No poetry. We are looking at the rigorous neuroscience and the neuroendocrinology of nature exposure. We are talking about how specific environments induce structural changes in your brain, how they alter the network connectivity between different lobes, and how they shift regional activation.
And we are backing all of this up with a pretty massive stack of research today.
Oh, absolutely. We're looking at over 3 decades of peer-reviewed scientific literature. We'll be tracing the evolution of this field, starting from some foundational behavioral psychology in the 80s and 90s, right up through the advent of mobile EEG mapping in fMRI scans.
I mean, we even have the absolute cutting-edge data from 2024.
Yes. Specifically looking at event-related potentials, or ERPs, published in top-tier neuroscience journals. But to really grasp how nature repairs the biological hardware of the brain, we have to start by looking at what modern urban life is currently doing to break it.
Which I think is a great place to anchor this. Because for a long time, the idea that a forest was, good for you was just folksy wisdom. Where did it actually cross over into measurable science?
So the conceptual framework really crystallized in 1984 with the Biophilia hypothesis.
Okay.
This was put forward by E.O. Wilson, the legendary evolutionary biologist. He basically posited that humans have this innate, hardwired evolutionary connection to nature.
Right.
And, you think about it, anatomically, modern humans have been around for roughly 300,000 years.
Right.
We spent over 99% of that evolutionary history adapting to and surviving in natural environments. So our physiological systems, our sensory processing, our psychological baseline, they were all built to function optimally in a savanna or a forest, not a concrete grid.
Yeah, our brains didn't evolve to process the sound of a garbage truck backing up or the flicker of a fluorescent light. We are essentially running this incredibly ancient software on modern, highly stressful hardware.
Exactly. But Wilson's hypothesis, while brilliant, was largely theoretical. The leap from evolutionary theory to measurable physiological data came a few years later with something called stress reduction theory, or SRT.
And this is Roger Ulrich, right?
Yes, the pioneer here was Roger Ulrich. In 1991, he published this foundational paper in the Journal of Environmental Psychology. It was called Stress Recovery During Exposure to Natural and Urban Environments.
I was looking at the methodology for Ulrich's paper, and it is just phenomenal early 90s lab science. He didn't just give people a questionnaire asking, hey, you feel more relaxed looking at this tree?
Now, self-reporting is always tricky.
Exactly. He wanted to see what the autonomic nervous system was doing without any conscious bias from the participants at all, so he actually measured their sweat.
He did. He hooked participants up to a 0.5-volt constant voltage Colburn skin conductance coupler.
Which sounds like a torture device.
It sounds intense, yeah. But to translate that for anyone who hasn't been in a psychophysiology lab, he basically placed standard silver and silver chloride electrodes right on the second joints of their ring and middle fingers.
Right.
And he used this highly conductive Johnson & Johnson KY jelly as an electrolyte to get a perfect, pristine read on the skin.
Which is basically a highly sensitive lie detector test. Because when you get stressed, your sympathetic nervous system, your fight or flight response kicks in. And one of the very first things that happens before you even consciously realize you're stressed is that your palms start to sweat microscopically.
Exactly, to prepare you to grip things, to run, to fight.
Right. And Ulrich was measuring spontaneous fluctuations in that sweat gland activity down to 0.067 microsiemens. Which, for the listener, is an incredibly tiny electrical change.
It's microscopic.
Right.
And the findings are just undeniable. He exposed these participants to stressors, got their nervous systems all worked up, and then showed them either urban environments or natural environments.
Now what happened?
For the people exposed to nature, that microscopic sweat gland activity just plummeted. The autonomic nervous system shifted out of fight or flight almost immediately. We're talking about physiological recovery happening in less than 5 minutes.
Wow.
The body recognizes the natural environment and literally sends a stand-down order to the adrenal glands.
So that's the physical stress response. But what about the mental side? Because I know I can be sitting perfectly still, perfectly safe, not physically stressed at all, but completely mentally exhausted just from staring at a spreadsheet all day.
Yeah, that brings us to the second massive pillar of this field, attention restoration theory, or RT.
Okay, RT.
This was developed by environmental psychologists Stephen and Rachel Kaplan. They laid this out in a series of highly influential papers, particularly their 1989 work and a major 1995 paper, also in the Journal of Environmental Psychology, called The Restorative Benefits of Nature, toward an integrative framework.
Right.
Where Ulrich focused on the stress response of the body, the Kaplans focused on the cognitive battery of the mind.
This concept completely changed how I think about my workday, honestly. Because the Kaplans proposed that we don't just have one generic type of attention, they split it into two distinct categories.
Right, they separated it.
The first is directed attention. This is the kind of focus you use when you are trying to write a complex email, or when you're driving in heavy traffic, or trying to understand that dense spreadsheet. It requires active, burning effort.
It's effortful because you aren't just focusing on the task, you are actively blocking out everything else around you. And the Kaplans contrasted that with what they called involuntary attention, or a term they coined that I absolutely love, soft fascination.
Soft fascination? It sounds like an indie jazz album.
It really does.
Yeah.
But neurologically, soft fascination is what happens when you are watching a campfire flicker, or watching a stream flow over some rocks, or just looking at clouds moving across the sky.
The stimuli are just inherently interesting.
Exactly. They capture your attention completely effortlessly. They don't demand any heavy cognitive load. And because of that, they allow your directed attention mechanisms to power down and actually rest.
Let me make sure I'm fully wrapping my head around this because it feels like a really crucial point. In a 2010 paper in Perspectives on Psychological Science, Kaplan teamed up with another researcher, Mark Berman.
Right, the Berman paper.
Yeah. The paper was called Directed Attention as a Common Resource for Executive Functioning and Self-Regulation. And they basically argued that self-regulation, which is your ability to not snap at your coworker, or your ability to stick to a diet or to keep studying for a test, is a finite resource. It's a battery. And when it drains, you suffer from mental fatigue.
That is the core of it. Self-regulation is always pitting your long-term intentions against your short-term inclinations. You intend to finish the report, but you are inclined to scroll on your phone. To maintain the intention, you have to use directed attention.
But why does an urban environment drain that battery so much faster than a forest? I mean, if I'm just walking down a city street, I'm not actively trying to solve a math problem. Why am I getting mentally fatigued just by being in a city?
To understand that, we have to understand how the brain actually pays attention to things. And this is where things get a bit counterintuitive. When you focus on something, your brain doesn't just turn on a spotlight and illuminate the thing you want to see. It actually works by plunging everything else into darkness.
You brought up an incredibly strange analogy for this in the notes you sent over, and I want to dive into it because it completely blew my mind.
The E. coli paper.
Yes. You referenced a 1992 paper by Kevin Dunbar called How Scientists Really Reason. And this paper isn't even about psychology. It's about the 1965 Nobel Prize-winning discovery in bacterial genetics by François Jacob and Jacques Monod. I was reading this thinking, what on earth does E. coli have to do with my attention span?
I know, it seems like a massive detour, but the mechanical parallel is just flawless. So Jacob and Monod were trying to figure out how E. coli bacteria regulate their genes. Specifically, how do they switch on the production of an enzyme called beta-galactosidase when lactose is present.
Because they need the enzyme to digest the lactose.
Right. And the assumption for years was that there was a switch. Lactose shows up, the gene switches on, the enzyme is made.
Which makes logical sense. You need the tool, you turn on the factory.
Exactly. But what they actually discovered was entirely different, and it won them the Nobel Prize. The control mechanism wasn't a switch, it was an active inhibitor. There is a regulator gene, the I gene, that constantly produces an inhibitor protein. And this protein actively binds to the operator gene, the O gene, and completely blocks the production of the enzyme.
That is holding it back.
Yes. The default state of the cell is active energy-consuming suppression. It's only when lactose enters the cell that the inhibitor binds to the lactose instead of the gene. This removes the suppression, and the enzyme is naturally produced.
Okay, so the factory isn't waiting to be turned on. The factory desperately wants to run all the time. And the cell is spending massive amounts of energy holding the off button down. And this is how human attention works.
Exactly. Directed attention is fundamentally an inhibitory mechanism. When you are walking down a busy urban street, your environment is flooded with what neurologists call bottom-up stimuli.
Meaning things trying to grab your attention.
Right. These are sudden, high-intensity signals designed by nature to hijack your attention to keep you alive. A jackhammer going off, a siren wailing, a massive digital billboard flashing neon colors, a crowd of people moving unpredictably.
So my brain is essentially that E. coli cell. I'm trying to hold on to my top-down goal, which is just to walk to the coffee shop and think about my afternoon meeting. To do that, my prefrontal cortex has to act like that E gene. It has to constantly generate inhibitory signals to suppress the jackhammer, suppress the flashing lights, suppress the sirens.
Yes.
I'm not just walking. I'm actively fighting off 100 cognitive hijackings every single minute.
And cognitive inhibition requires profound metabolic resources. It drains your neural battery at an astonishing rate. You don't realize you're doing it, but by the time you reach the coffee shop, your prefrontal cortex is exhausted. You are suffering from directed attention fatigue.
Wow.
So the scientific question naturally became, if urban life is actively draining this inhibitory battery, can we prove that nature plugs it back in?
Which transitions us perfectly from theory into hard, measurable behavioral evidence. Because we all intuitively feel better after a walk in the park. But how do you actually measure an invisible cognitive battery?
You test it using gold standard cognitive metrics. In 2008, Mark Berman, John Gennadies, and Stephen Kaplan published a landmark study in psychological science. It was titled The Cognitive Benefits of Interacting with Nature. They wanted to see if they could objectively measure attention restoration theory, so they brought people into the lab and gave them a backwards digit span task.
I've actually taken one of these for a different project, and they are infuriating. They read you a string of numbers like 72951, and you have to repeat them back in reverse order. 15927. It sounds easy, but it requires massive amounts of working memory and executive control. You have to hold the numbers in your head and mentally manipulate them.
It is a perfect stress test for the prefrontal cortex. Berman's team also used the Attention Network Task, or ANT. That flashes arrows on a screen and forces you to identify the direction of a central arrow while ignoring surrounding arrows that point the wrong way. It literally measures your ability to inhibit distractions.
So they baseline them, drain the battery, and then what were the results?
Well, after the baseline tests, which purposefully drained their cognitive battery, they sent them on a 50-minute walk. Half the group walked through a leafy arboretum, and the other half walked down a busy commercial street. When they came back and retook the tests, the nature group showed massively significant improvements in their directed attention abilities. The urban group showed almost no improvement. The city walk didn't rest their brains at all.
And I really want to point out to you listening that this wasn't just a fluke finding from one lab. I'm looking at a 2016 paper published in the Journal of Toxicology and Environmental Health by a researcher named Heather Oley and her team.
The systematic review.
Yes, it's a systematic review literally titled Attention Restoration Theory. And for anyone who might not read academic journals, a systematic review is when researchers gather up dozens of independent studies from all over the world, pool all the data together, and run statistical analyses to see if a trend holds up across thousands of people.
It's the highest level of evidence we have in science. And Oley's review confirmed that exposure to natural environments consistently yields significant positive effects on the digit span forward test, the digit span backward test, and something called the trail making test B, which is this brutal test of task switching and visual attention. The battery recharge is real, and it is universally measurable.
But I want to push on the implications of this, because improving my score on a backwards number test in a lab is cool, but it doesn't really explain why I should care in my daily life. How does this degraded cognitive battery actually show up in my behavior?
That is the crucial question. And Berman followed up on exactly this in 2011 with a paper called Behavioral and Neural Correlates of Delay of Gratification 40 years later. They wanted to see what happens to our self-control when that directed attention battery is drained. They took people who were already cognitively depleted and put them through a no-go trial.
Explain the no-go trial, because this is fascinating.
So in a standard go-no-go task, you are looking at a screen, and you're told to press a button as fast as you can every time a specific image pops up, say, a neutral face. That builds up a physical habit. You get used to pressing the button. But if a different image pops up, a no-go target, you have to inhibit that physical impulse and stop yourself from pressing the button.
So it's testing your mental brakes.
Exactly. But Berman used hot stimuli. Instead of just neutral shapes, the no-go targets were highly emotional faces, very happy or very fearful. Emotional stimuli naturally hijack our attention.
Right.
And what they found was that when individuals are cognitively depleted, when their directed attention battery is low, their mental brakes just fail. For individuals who already struggle with delayed gratification, their commission errors, meaning they pressed the button when they were supposed to stop, hit almost 16% on those hot, happy trials.
Think about the real-world equivalent of this. You've had a long, cognitively draining day at work in a loud city. You are suffering from directed attention fatigue. Your mental brakes are completely worn out. On the way home, you walk past a bakery, or you get an impulse to snap at your partner, or you see something you want to impulse buy on your phone. Because your inhibitory network is depleted, you literally lack the neurological hardware to say no to that impulse.
That's precisely the danger. And it's backed up by a brilliant 2014 paper by Butin de Court called Natural Resistance: Exposure to Nature and Self-Regulation, Mood, and Physiology After Ego Depletion.
Ego depletion.
Yeah, that's what they call that state of severe mental fatigue. They deliberately induced ego depletion in participants. Then they showed them either photos of the Eindhoven city center in the Netherlands or photos of the Strabrechtseheide, which is this beautiful, sweeping, natural woodland and heath.
And just looking at the photos did something.
Yes. The natural scenes significantly restored their self-regulation and cognitive resources compared to the urban scenes.
Okay, so the science says nature restores the battery. But a big question I have, and I'm sure anyone listening has, is about dosage. How much nature do I actually need? Do I need to quit my job and move to a cabin in the woods, or can I just look at a fern on my desk?
The dosage question is one of the most active areas of research right now. And we generally split it into macro doses and micro doses. If we want to look at the absolute gold standard for a macrodose, we have to look at the famous 3-day effect.
Yes, let's talk about the 3-day effect. This comes from a 2012 paper by David Strayer and Ruth Ann Atchley, published in PLS One, called Creativity in the Wild. The setup for this study sounds like a vacation I desperately need.
It's an incredible study. They took a group of adults on an outward-bound backpacking trip, 4 full days deep in the wilderness. And the crucial element was that they stripped away all technology. No smartphones, no tablets, no digital cameras, total sensory immersion in a natural environment with 0 digital bottom-up distractions.
And what were the cognitive results of completely unplugging for that long?
On the 4th day, they gave the participants a test called the Remote Associates Test, or RAT. It's a complex measure of creative reasoning and insight problem solving. The participants who had been immersed in nature showed a massive 50% improvement in their scores compared to the control group, a 50% leap in high-level cognitive functioning.
That is absurd. If a nootropic supplement boosted your brain power by 50%, it would be $1 trillion industry. And the implication here is that this isn't giving them superpowers, it's just removing the constant low-grade brain drain of modern life. It allows their executive attention system to fully reboot, which unlocks higher-order creative processing that is normally just crushed by everyday mental fatigue.
Exactly. When you don't have to spend 80% of your mental energy inhibiting distractions, you have all that energy available for deep creative thought.
But let's be realistic. Most of you listening to this right now cannot drop everything, abandon your emails, and go backpacking in the wilderness for 4 days. What happens on a Tuesday afternoon when you are stuck in an office? Does a microdose do anything?
It absolutely does, and the data on this is incredibly encouraging. There's a 2015 paper by Kate Lee published in the Journal of Environmental Psychology titled 40-Second Green Roof Views Sustain Attention.
40 seconds. That's barely enough time to drink a glass of water.
It is incredibly brief. They took university students and subjected them to a painfully boring, repetitive, sustained attention task. Just brutal, mind-numbing work. Halfway through the task, they gave them a microscopic break. Half the students looked out a window at a standard, bare, concrete city roof. The other half looked out a window at a city roof that had been planted as a green, flowering meadow.
And in just 40 seconds, what happened?
The group looking at the green roof made significantly fewer omission errors on the second half of the sustained attention task than the concrete group. Even in that tiny window of time, their subcortical arousal and cortical attention control were measurably boosted. The visual interaction with soft fascination provided an immediate, measurable bump in performance.
But what if you don't even have a window? What if you are listening to this right now in a windowless cubicle or you're driving a truck down an interstate?
You don't even need to physically see nature. In 2019, Stephen Van Hedger published a paper and brief report called Of Cricket Chirps and Car Horns. They wanted to isolate the auditory component of nature. They had people listen to either natural soundscapes like crickets, birds, running water, or urban soundscapes like traffic and car horns.
And they tested them on a dual end-back task, right? Which is another one of those torturous cognitive tests where you have to keep track of a changing sequence of both audio and visual cues simultaneously. It just melts your brain.
It's extremely taxing. And the group listening to the nature sounds showed improved directed attention on the dual end-back compared to the urban sound group. But here's the kicker, the part that really surprised the researchers. It improved their cognition even if the participants didn't report feeling any happier or more relaxed.
Wait, really? So they didn't subjectively feel a mood boost, but their brains performed better anyway?
Yes. And that is a monumental finding because it proves that this operates on a physiological hardware level. It is completely independent of whether you consciously feel relaxed. The acoustic structure of natural sounds, the frequencies, the patterns, physically repairs the cognitive machinery regardless of your subjective mood.
Okay, this is the perfect moment to pivot. We've talked about the behavioral test, how people act and perform after being in nature, but I want to look under the hood. I don't just want to know that the engine runs better. I want to see the spark plugs firing. What is physically happening inside the meat of the brain when we hear those crickets or see those trees?
This brings us to the neurocore of our deep dive, regional activation and network connectivity. And to start, we have to talk about a groundbreaking 2015 paper by Gregory Bratman, published in PNAS. It's called Nature Experience Reduces Rumination and Subgenual Prefrontal Cortex Activation.
Rumination is a nasty word in psychology. For anyone who hasn't encountered the clinical definition, rumination is that toxic, repetitive pattern of negative, self-referential thought. It's when you are lying awake at 2 a.m., replaying a slightly awkward conversation you had 5 years ago, or fixating on a perceived failure over and over. It's a massive predictor for severe depressive episodes.
It's the mind stuck in a negative loop. And Bratman wanted to see if nature could physically break that loop. So he sent participants on a 90-minute walk. One group walked in a pristine natural setting in Oak Woodland in California. The other group walked along El Camino Real, a multi-lane, heavily trafficked urban road in Palo Alto.
Both groups are walking the exact same amount of time, getting the exact same amount of exercise.
Precisely. But only the nature walkers reported a significant decrease in rumination. However, Bratman didn't stop at self-reporting. He put these participants into an fMRI scanner to look at the blood oxygen levels in their brains. And he found that the nature group showed severely decreased neural activity in a very specific region, the subgenual prefrontal cortex, or SGPFC.
And why is the SGPFC so important?
The SGPFC is intimately tied to behavioral withdrawal and the onset of clinical depression. When people are deeply depressed and trapped in rumination, their SGPFC is glowing hot on an fMRI. It's working overtime. The fact that a simple 90-minute walk in an oak woodland physically downregulates a brain region associated with mental illness is staggering.
It's essentially a form of spatial therapy. You are using geography to alter blood flow in the brain. But it's not just about turning one specific region down, right? The brain is a network. How does nature affect how different parts of the brain talk to each other?
For that, we look at a 2010 study by Kim and his team called Human Brain Activation in Response to Visual Stimulation with Rural and Urban Scenery Pictures. They also used fMRI, but they were looking at functional connectivity. They discovered that viewing nature actually increases the connectivity between the insula and the anterior cingulate cortex, or the ACC.
Let's break that down. The insula and the ACC. Why does it matter if those two areas are talking to each other more efficiently?
Think of the pathway between the insula and the ACC as a critical neural highway for emotional regulation. The insula monitors the internal state of your body, your heart rate, your breathing, your gut feeling. The ACC is involved in decision-making and impulse control. When this pathway is strong, you can feel your body getting stressed, and your brain can immediately intervene to calm it down.
It's a feedback loop.
Exactly. By strengthening this specific connection, nature is essentially upgrading your brain's shock absorbers. You become neurologically more resilient to stress.
Okay, so fMRI shows us the blood flow. It shows us where the activity is happening, but fMRI is a bit slow. It captures changes over seconds. What about the actual electrical rhythms of the brain, the split-second processing?
To capture that, you need EEG electroencephalography. And traditionally, that meant sitting in a dark, shielded room with a gel cap on your head. But in 2017, Hopman and Strayer published a paper called Measuring Cognition in Nature. Technology had finally advanced to the point where they could take high-quality mobile EEG equipment out into the wild. They could measure brain waves in real time as people walked through a forest.
And what did the electrical waves show?
They focused on a specific electrical rhythm called midline frontal theta frequency, which operates around 4 to 8 hertz. Midline frontal theta is positively correlated with high cognitive control and the activation of the frontoparietal attentional control network, or the ACN.
So high theta means your brain is working hard to pay attention.
Yes. And when subjects were exposed to nature, their midline frontal theta frequency significantly decreased.
If I'm understanding this correctly, a drop in that frontal theta frequency essentially means my brain gets to take its foot off the cognitive gas pedal.
Exactly. The attentional control network is finally downregulating. It's resting. You aren't forcing your brain to focus. But, and this is the beautiful part of the Hopman study, they also measured posterior alpha frequency, which sits around 8 to 12 hertz. This frequency also decreased.
Why is a decrease in posterior alpha important?
Because a decrease in posterior alpha indicates that the brain is still engaged with its environment. It's not asleep, and it's not just numbly wandering. It correlates perfectly with the Kaplan's idea of soft fascination. It proves that soft fascination is a neurologically distinct state from either intense focus or pure boredom. The brain is engaged by the rustling leaves and the light filtering through the trees, but in a way that requires zero executive effort.
And when this exhausted attentional control network finally powers down, something else powers up to take its place, right? The default mode network.
Yes, the DMN. The default mode network is a vast, interconnected set of brain areas that become highly active only during restful introspection. When you stop actively directing your attention outward at tasks and threats, the DMN lights up.
And the DMN isn't just idleness. It's doing crucial background work. It's like when your computer goes to sleep and it suddenly starts running all the defragmentation and virus scan programs. The DMN is responsible for memory consolidation, thinking about the future, empathy, and maintaining what researchers call peak psychosocial health.
If we pull back and look at our modern reality through this lens, it's actually quite terrifying. David Strayer, who we mentioned earlier, did some seminal work in 2001 and 2006 on distracted driving. He used a massive, high-fidelity patrolsome driving simulator to see how unpredictable urban events, sirens, and the cognitive load of cell phones degrade our attention.
We've all been there. You're navigating heavy traffic in the rain, listening to something, your smartwatch is vibrating with a text message, and you're actively suppressing the urge to honk at the guy who just cut you off.
In that moment, your attentional control network is just redlining. It is screaming. Modern life forces us into this state of constant, high-arousal multitasking. And because we never turn it off, the default mode network rarely gets a chance to run its maintenance. Nature is the biological trigger that literally shifts the brain's gears out of this toxic overdrive and lets the DMN take over.
But reading through the history of the science, it seems like there was a lingering mystery. For decades, attention restoration theory proved that attention was restored, but attention is a huge, complex umbrella term. It wasn't until literally this year that scientists figured out exactly which specific wire in the brain nature was repairing.
That is exactly right.
I want to spend some time on this because the experimental setup here is brilliantly rigorous. In older studies, critics would often say, well, maybe the people in nature just walked faster and got more exercise, and the exercise made their brains work better. How did McDonnell and Strayer eliminate those variables?
They designed an incredibly tight protocol. They took 92 participants and deliberately depleted their cognitive resources. They used a counting backwards task, specifically serial sevens, where you have to subtract 7 from a large random number over and over as fast as you can. It is incredibly frustrating and rapidly induces severe mental fatigue.
So they drained the battery completely. Then what?
Then they randomly assigned them to take a 40-minute walk. Half went to a natural environment, the Redbud Garden in Utah, and half went to an asphalt medical campus. But here's the genius part. They controlled for everything. The walks were perfectly matched for distance, roughly 1.9 miles. They were matched for elevation change. They were matched for temperature and humidity. And most importantly, they tracked the physical exertion of every participant, ensuring both groups maintained an identical average heart rate of around 108 to 110 beats per minute.
So the physical output, the cardiovascular exercise, was identical. The only changing variable was the visual and auditory environment.
Exactly. After the walk, they brought them back to the lab, hooked them up to high-density EEG caps, and had them run the attention network task, the ANT. Now, cognitive neuroscience breaks attention down into 3 distinct measurable networks: alerting, orienting, and executive control.
Let's define those briefly so we understand what's at stake here.
Alerting is your basic state of vigilance. It keeps you awake and ready to respond to a stimulus. Orienting is your ability to select spatial information, like turning your head when you hear a sound. And executive control is the big one. It's the highest level of cognition. It manages competing demands, resolves complex conflicts, and overrides deep-seated impulses.
And for decades, the Kaplan's theory didn't specify which of those 3 was actually being repaired. What did the 2024 data show?
The breakthrough was that the alerting and orienting networks didn't change at all. Nature had 0 effect on them. Whether you walked in the trees or on the asphalt, your basic vigilance was exactly the same. But the executive control network showed a massive divergence. Specifically, the researchers measured an event-related brain component called the error-related negativity, or the ERN.
What exactly is an ERN? Is it a brainwave?
It's an electrical spike. It originates in the anterior cingulate cortex, which we talked about earlier. The ERN is essentially the brain's "oh crap" signal. It fires within milliseconds of your brain detecting a conflict or realizing you just made an error, even before you're consciously aware of the mistake.
So it's the internal alarm system going off.
Yes, and a stronger, larger amplitude ERN is actually a very good thing. It means your prefrontal cortex is highly efficient. It means your brain's highest level executive manager is alert, fully recharged, and ready to flawlessly manage competing demands. The 2024 study proved that the ERN was significantly enhanced only in the nature group.
Let that sink in. Just a 40-minute walk in nature with no extra physical exertion gives your brain's highest level executive manager a massive, measurable electrical upgrade in its ability to detect and correct errors. Nature specifically targets and repairs the exact cognitive network responsible for your most complex, high-level thinking.
It is stunning precision from an environmental intervention. And it's important to realize that this electrical repair in the brain doesn't happen in a vacuum. It is intimately linked to the neuroendocrinology of the rest of the body. In 2020 and 2021, Scott and Strayer published work in the Parks Stewardship Forum titled "Toward a Unified Model of Stress Recovery and Cognitive Restoration in Nature." They basically argued that we have to stop looking at the brain and the body as 2 separate things.
Right, it's a unified biological system.
Precisely. They proposed that nature acts as a systemic trigger. Visual and auditory soft fascination triggers the parasympathetic nervous system via the vagus nerve. This is the rest and digest mode. Vagal tone increases, which stabilizes cardiovascular regulation. Cortisol, the primary stress hormone that damages neural tissue over time, begins to stabilize and drop.
And how does that hormonal shift help the prefrontal cortex fire that massive ERN spike?
Because it stops the metabolic bleeding. When you are in sympathetic fight-or-flight mode in the city, your body is frantically burning up neurophysiological resources, like glucose and dopamine, to fuel constant vigilance. When nature triggers the parasympathetic state, that burning stops. The glucose and dopamine, the literal chemical fuels that power the prefrontal cortex, are finally allowed to pool and replenish. The battery physically recharges with neurochemicals.
So we have a perfectly mapped mechanism, from the sweat on your fingers to the vagus nerve to the glucose in your brain to the electrical spike of the ERN. We know exactly what a 40-minute walk does to a fully formed adult brain. But that leads me to an absolutely crucial question. If a single walk has this profound of a neurological effect on an adult, what does a lifetime of green space or a total lack of it do to a developing brain?
This is where the science shifts from personal health optimization to massive public health implications. And we are going to look at one of the most staggering epidemiological studies I have ever read.
Yeah.
In 2018, Christine Engemann and her team published a paper in PNAS titled Residential Green Space in Childhood and Lower Risk of Psychiatric Disorders.
I was going through the methodology of this paper, and the sheer scale of the data is mind-boggling. They didn't just study a couple of hundred kids in a lab. They used Landsat satellite data going all the way back to 1978 through 1983.
Yes, they used high-resolution satellite imagery to map the precise amount of green space, the normalized difference vegetation index, around the childhood home of literally the entire population of Denmark.
Millions of people. They essentially built a geographical nature exposure profile for every single child growing up in the country over a span of years.
And because Denmark has an incredible centralized national health registry, they were able to cross-reference that satellite data with the long-term psychiatric health outcomes of those exact same individuals as they grew into adulthood. They tracked them for decades to see who developed mental illnesses and who didn't.
And what happens to a child's brain when it develops in a completely urban, concrete environment versus a green environment?
The findings should fundamentally change how we build cities. Children who grew up surrounded by the lowest levels of green space had up to a 55% higher relative risk of developing psychiatric disorders later in life.
55%.
A 55% increased risk. And this wasn't just mild anxiety. This included severe pathologies, schizophrenia, mood disorders, severe depressive episodes, and substance abuse disorders. And Engemann's team controlled for everything you could think of: socioeconomic status, family history of mental illness, parental age, urbanization index. Even when you strip all those confounding variables away, the protective effect of nature remains overwhelmingly robust.
That is profound. We aren't just talking about giving kids a nice place to play. We are talking about the structural development of the brain. If a child's prefrontal cortex is constantly subjected to bottom-up urban stimuli, constantly drained of its directed attention, and never allowed to activate the default mode network for repair, the neurological hardware literally develops vulnerabilities that manifest as severe psychiatric disorders decades later.
It is a pure epidemiological risk factor. And because we can now quantify that risk, economists have actually started to put a financial value on what this nature provides to a society. It's a concept known as ecosystem services.
I love when economists get involved in biology because they put brutal price tags on things we normally just view as nice. You brought up a 2017 review by Hansen that detailed a major study done in Toronto.
Yes, this study is a brilliant example of quantifying biological buffering. They analyzed the health data of the population block by block in Toronto and correlated it with the density of the tree canopy. They found that planting just 10 more trees on a single city block improved the local population's self-perception of health to a degree that was mathematically equivalent to every person on that block receiving a $10,000 increase in their personal annual income.
10 trees gives you the same health and happiness bump as a $10,000 raise.
And it gets more specific regarding actual physiological pathology. Having 11 more trees on a block decreased the incidence of severe cardiometabolic conditions like hypertension, obesity, and diabetes to an extent equivalent to a $20,000 raise in income. The biological buffering effect of nature, the reduction in cortisol, the lowering of sympathetic nervous system arousal, has a direct, calculable economic value in preventative health care. Nature is literally saving the medical system billions of dollars just by sitting there.
But it goes even further than just keeping us out of the hospital. It actually changes the fundamental nature of how we interact with other human beings. Let's talk about the trust game.
This is a fascinating behavioral angle. In 2013, Dr. Keltner and Jiawei Zhang ran a study looking at pro-social behavior. They wanted to know if nature makes us better, more generous people. They exposed participants to very beautiful, awe-inspiring natural scenes and then had them play an economic game where they had the option to share points, which translated to real money with a completely anonymous partner.
The classic setup to see if people will be selfish when no one is watching.
Exactly. And what Keltner and Zhang found is that exposure to beautiful nature triggers a specific psychological state that they beautifully termed unselfing.
Unselfing. Let's dig into that, because it sounds almost spiritual, but there's hard psychology behind it.
It describes a profound diminishment of the ego. When you experience awe in nature, when you look at a towering redwood or a massive mountain range, your brain shifts its focus away from your own immediate selfish needs and desires. You feel small, but in a comforting way. You feel integrated into a larger collective.
And how did that manifest in the game?
The participants who experienced this unselfing showed radically increased pro-social behavior. They gave away an average of 59% of their points to their anonymous partners. They became remarkably generous and trusting simply because the natural environment had diminished their ego-driven anxiety. Nature literally makes us less selfish.
And it protects us from our own worst emotional impulses. There's one more paper we need to cover that brings the emotional regulation aspect full circle. Bratman and Gross published a paper in 2021 called The Effective Benefits of Nature Exposure. They used something called the process model of emotion regulation to explain how nature acts as an emotional shield.
This paper brilliantly synthesizes everything we've talked about. They frame nature as providing a highly effective form of positive distraction, which, in psychological terms, is called attentional deployment.
How does that differ from the rumination we talked about earlier with the fMRI scans?
When you are ruminating, you are deploying your attention inward toward negative self-referential thoughts. Usually, to stop ruminating, you have to use effortful cognitive suppression. You have to force yourself to stop thinking about it, which drains your directed attention battery even more. It's a vicious cycle. But nature provides soft fascination. It naturally, effortlessly pulls your attentional deployment outward toward the rustling leaves or the clouds.
So it breaks the negative loop without asking you to spend any mental energy to do it.
Exactly. It seamlessly shifts your focus away from the rumination without requiring the effortful cognitive suppression that drains your executive function. It heals your emotional state without asking anything of you.
I think this is the perfect moment to step back and look at the whole picture we've painted today. If you are listening to this right now, whether you are prepping for a highly stressful meeting, or you are trying to recover from a bout of severe burnout, or you just feel constantly overwhelmed by the endless stream of notifications on your phone, the science is screaming a very clear message at us. Staring at a screen, scrolling through social media, or playing a quick mobile game on your lunch break, that is not a break for your brain.
It's an illusion of rest.
Right. It feels like you are resting your body, but you are still forcing your prefrontal cortex to process high-intensity, bottom-up stimuli. You are still draining the battery. Your brain physically, biologically, needs the soft fascination of the natural world to repair your error-related negativity. It needs the acoustic frequency of a natural environment to downregulate your subgenual prefrontal cortex.
And understanding this immense body of evidence isn't just a matter of optimizing your personal health or hacking your afternoon productivity. It is fundamentally about how we design the future of human habitation.
So let's wrap up the massive scope of what we've covered in this deep dive. We have traced the evidence across decades of rigorous science. We looked at the microscopic fluctuations of sweat on the fingertips in Roger Ulrich's 1991 psychophysiology lab. We've measured the split-second electrical firing of the brain's executive manager in McDonald's 2024 EEG trials. We've even looked from space, using Landsat satellites to track the childhood psychiatric risks of millions of people across Denmark with Engman in 2018.
The overarching conclusion is inescapable. The natural world is not just a luxury amenity. It's not just a nice place to visit on the weekend. It is a strict neurological necessity for executive function, emotional regulation, and fundamental human thriving.
Which leaves us with a final provocative thought to mull over. We've established all this science. If we can now objectively measure the exact neurological deficit caused by urban environments, and if we can prescribe the exact dose of nature down to the 40-minute mark required to reverse that deficit, where does that leave the people building our cities?
It opens up a fascinating, almost science fiction level legal and medical frontier. Could we soon see a future where urban planners, architects, and real estate developers are held medically and legally liable for the cognitive damage caused by their concrete landscapes? If we know a neighborhood without trees causes a 55% increase in childhood psychiatric disorders, does building that neighborhood become a form of public health negligence?
That is wild to think about.
What if, in the very near future, landscaping ceases to be an aesthetic choice made by a designer and instead becomes a highly regulated branch of pharmacology? Imagine a world where your doctor doesn't just prescribe a pill for your attention deficit or your depressive episode. They prescribe the installation of specific species of trees outside your bedroom window, or a specific fractal pattern of a flowering green roof for your office building, perfectly calibrated to repair your specific cognitive deficits.
A world where architecture and pharmacology merge. That is an entirely plausible and honestly incredibly hopeful future. Thank you for joining us on this incredibly deep dive into the mind, the body, and the environment. Take a real break today. Step outside, leave the phone in your pocket, let your directed attention rest, let your default mode network take over, and let nature do the work. We'll catch you on the next deep dive.